Introduction to solar influence. The sun plays a fundamental role in shaping the Earth's climate. Its energy drives weather patterns, temperature variations, and the overall climate system. Understanding the sun's influence helps us grasp how climate works and the factors affecting long-term changes in the Earth's climate. Solar energy and temperature. The sun's energy reaches Earth in the form of solar radiation. This radiation warms the Earth's surface, influencing global temperatures. The amount of solar energy received at different latitudes varies due to the Earth's tilt and orbit. This variation leads to different climate zones, such as tropical, temperate, and polar regions, each receiving varying amounts of solar energy throughout the year. Greenhouse effect. The sun's energy is crucial for the greenhouse effect, a natural process that warms the Earth's surface. Solar radiation penetrates the atmosphere and reaches the ground, where it is absorbed and then re-radiated as infrared energy. Greenhouse gases in the atmosphere, such as carbon dioxide and methane, trap some of this infrared radiation, preventing it from escaping back into space. This trapped heat helps maintain the Earth's temperature within a range suitable for life. Solar cycles and climate variability. The sun undergoes regular cycles of activity, including the 11-year solar cycle, during which solar radiation and sunspot activity fluctuate. These cycles can influence Earth's climate, affecting factors like global temperatures and weather patterns. For example, periods of high solar activity can slightly increase global temperatures, while periods of low activity may contribute to cooling. Solar radiation and weather patterns. Solar radiation drives atmospheric circulation and weather patterns. The uneven heating of the Earth's surface creates temperature gradients that drive wind and ocean currents. These currents, in turn, influence weather patterns such as the trade winds, westerlies, and jet streams. The distribution of solar energy affects precipitation patterns, storm systems, and seasonal variations. Impact on climate change. While the sun is the primary driver of Earth's climate, changes in solar radiation can contribute to climate change. Variations in solar output can influence long-term climate trends. For instance, periods of reduced solar activity, such as the Little Ice Age, are associated with cooler temperatures. However, the current trend of global warming is primarily driven by human activities, such as increased greenhouse gas emissions, rather than changes in solar radiation. Solar influence on the hydrological cycle. Solar energy also impacts the Earth's hydrological cycle by driving evaporation and precipitation. The heat from the sun causes water to evaporate from oceans, lakes, and rivers, forming clouds that eventually lead to precipitation. This cycle plays a key role in distributing fresh water across the globe and influencing weather patterns. Solar energy and climate extremes. Solar energy can also impact climate extremes, such as heat waves and cold spells. During periods of intense solar radiation, the Earth's surface warms more significantly, potentially leading to extreme heat events. Conversely, reduced solar radiation can contribute to colder conditions and increased likelihood of frost or snow. Long-term solar trends. Over geological timescales, changes in the sun's output and Earth's orbit have contributed to major climate shifts, such as ice ages and warm periods. Milankovitch cycles, which include variations in Earth's orbit and tilt, interact with solar radiation to influence long-term climate patterns. Conclusion. The sun's role in the Earth's climate is multifaceted, influencing temperature, weather patterns, and climate variability. Its energy drives the greenhouse effect, atmospheric circulation, and the hydrological cycle, shaping both short-term weather and long-term climate trends. While solar cycles can affect climate, current global warming is predominantly driven by human activities. Understanding the sun's impact helps us better comprehend the complex interactions that govern Earth's climate and its changes over time.